Hello everyone, my name is Joe Scorson, channel's called Scorson Enterprises, and today we're talking about something that I just finished probably not even 30 minutes ago. This project has been a pain in the ass, but it is finally up. It's not done, software is never done, but it's up, right? I got something to go and I could pretend that it doesn't exist for a little bit, right? So yeah, as the title says, I wrote an actor model in Zig. It was one of those situations I was like, man, I wish that this tool, this library existed, and then I remembered I'm a software engineer. So I went ahead and I made the thing, and it was honestly a lot of fun. And so today what we're going to do is go through the actor model, talk about the code, why it is the way it is, go through the tests, and then, yeah, talk about my experience writing it and stuff like that with Zig. I wrote it with Zig 0.14.0, which is also in the repo. So we're going to get right into it. I'm not going to waste you guys' time. This is my X, though. I will waste your guys' time a little bit. This is my Twitter account. If you guys could give me a follow on there, I greatly appreciate it. You see, I just posted it. Go follow Eva, right? She's cool. And yeah, a bunch of information on there. If you guys like to actively trade, check out my creator partnership with Lux Algo. You get 2 algos designed by me. You get these levels, which are machine learning levels, and you get these predictions, which are done by a neural network. It's like when you talk to ChatGPT and it gets more contextual with what you're talking about. As the market does stuff, it has a better idea of relevance than traditional indicators and stuff like that, and these levels aim to prey on that, and these predictions aim to help you with that. So yeah, this is the repo. Give that a check. Check that out if you guys like to actively trade. Obviously, it's a subscription, so the money helps me a lot, right? Broke college student here, just programming away. Open source libraries. I'm kidding. I love what I do, but I'm just, I do it for a reason, right? I want this to be my career. But so yeah, this is Inklist. If you guys know, in Scorson Enterprises, is the name of my actual business, and that is going to be starting a lot more as the summer goes on when I actually have time. But there's going to be the actual app that I'm still developing, and then there's going to be the Ink products, the Ink something products. And they're either going to be developer tools or just really niche stuff that I want, and so I make. And so this is the first one. It's called Inklist because it's an actor model, and you can have A-list actors, B-list actors. These are Inklist actors, right? And so, yeah, this is kind of the start of the Ink family, I guess. So yeah, I hope that you guys can't see that flickering, but I'm not going to go through and do this, like the example stuff on this, because I already did it like just on my own without this on, and it works. It's good. You guys can check it out. I'd appreciate a star on this as well. What we're going to do is, because this is an open source library, whoops, I didn't full screen that. I'm just going to talk about the code, right? It's already written. It's on there. You guys can look at it yourselves. Why won't this zoom in? There we go. And yeah, you guys can, like, it's already up there, so there's no point in me like hiding it. The whole point is that it is open source. Now, first thing that we're going to look at is 2 data structures that are also in their own GitHub repos. I'll put these at the end over here. And what these are is a lock-free queue and a concurrent hash map. It's not quite a lock-free hash map. But the point of these 2 data structures, it's not a video about these data structures, so I'm going to make this brief, is that when you have multiple threads doing stuff on them, you don't need to use a mutex. And so if we look here in my engine, right, it's a thread pool, but when we run, oh, well, this is a better example actually. When we want to put an actor into the hash map, I don't need to lock it with a mutex or anything like that. If I want to send a message, I just I have to get into that. What's a better example for that? In the poison, I do use a mutex just to like get everything right and then get everything off. Actually, I'll use the lock-free queue. Right? If I'm receiving something, if an actor is receiving something, there's no reason why I shouldn't be able to theoretically receive 2 things at the same time. But when you use a mutex, it just kind of, I don't want to say it's inefficient, but it could be more efficient when you use lock-free data structures. So in something like this, when you receive a message, the thread pool, which is the same thread pool, but this is a reference to it, will do the thing. And this message queue, I don't need to lock anything. I don't even think there's a mutex in this. There is a mutex. Oh, that I forgot to take out. Okay, whatever. So yeah, it's a concurrent hash map because I do need to use a mutex when I resize, and it is a lock-free queue. There's no mutexes needed when you do stuff to the queue, and there's no mutexes needed for putting and getting. But if you need to resize on a put, then like putting something into the hash map, then it'll use a mutex and then resize. So let's get into the first bit of this code, and that is the messages, right? These are the things that the actors can send back and forth. And yeah, the whole point is that this actually modifies the state of the struct that the user is saying is their actor, right? Because I'm gonna jump all over the place, right? This is in the test, if you make an actor and you want to modify it, right? If it has an array list of something, in this case it just stores the messages, and I want this to be done in a multi-threaded way with the actor model. That's what these messages do. Is I send these messages to the engine, and it'll just do it. Instead of me saying like, okay, let me make my thread pool, now let me make my mutexes, now let me do this, now let me do that. I have to make sure that I wait for everything properly. It's already done here. And there's payloads and makers, like, builders, so that way it is consistent. The whole point of this in my mind was to make a consistent way to write your code. It's consistent, it's predictable, and it's multi-threaded and performant because of the thread pool, right? It's concurrent. So we have this instruction payload. There's two kinds of messages that we could have. We could either have custom ones, which is just a string, or we could have function calls. And so the custom one is just obviously a string. And then the function one has the function to call, context, a dinit, and a clone, right? Because this is stuff to be done to the struct, right? So now that we have that, we have these messages, which contains a sender ID, who did this come from, and instructions, which is this payload, right? Again, consistency. So now when we init, it just makes a new message because you have to send it the instruction payload. You make the payload and then make the message. And then dinit is just de-initing it. If you guys are new to writing Zig, every time you make a struct, just first things first, do this to make it pretty and to tell everybody when you're just modifying yourself. And write your init and dinit, right? If you're new to this, because it'll just save you a lot of headaches to just put everything else on hold and just do that first. Cloning is just to clone the message, right? I feel like it would be a nice thing to have, and also it helps with ownership, right? And so we're going to go through that as well in tests. What you need to de-init yourself and what you don't. This might end up being a long video, but let's get into these make payloads. So make function payloads, you need an allocator, a sender ID, and then everything that goes into the function payload. And so then you just create yourself, right? Because it's a message. And then you just populate everything, and then you can return this message. Pretty straightforward. And then the same thing, but just not a function for when you make a custom payload. It's just whatever your thing is, and I'm duplicating the string in there so that way, because this is a new, this and this are not the same thing, right? So again, just another thing with ownership, what you have to de-init and what I de-init in my library. So now if we go to the actor here, this is where stuff actually happens. And so there are a few things need to be present in your actor that you're giving me. It needs to have a receive method for me to call. It needs to be able to be initialized, and I need to de-init it, right? So now, and it's generic as well. It's whatever its comp time, right? So you say, I want an actor. This is my type. And I'm like, cool. Here you go. So yeah, and so then in this struct, what does an actor have? An actor has an ID, and it's its own allocator. Its state, a message queue, a wait group, which is nice. Again, a queue mutex because I forgot to take it out. A stop flag, a thread pool, right? So and it's a reference to a thread pool because the engine has the actual thread pool, and yeah, I'm giving that's its own engine, and then self.threadpool. Where is this going on? Spawn actor gets that thread pool, right? So I'm not making a new one for it. I'm just giving it the one that engine has. So yeah, let's keep going. So in this init, pretty much we're just saying what everything is and we're initializing it, right? It's pretty straightforward if you've coded in Zig before. I'd assume you do if you're watching this video about an actor model in Zig, especially because I'm not coding this along because this did take me a bit. But so yeah, initializes it with a lock-free message queue and a thread pool, and so then it just returns itself. Pretty straightforward. I'm going to do the D init first because this will just go through and just say, this is your struct D-inited. Well, it's the whole thing stopped. Your struct D-inited, the message queue D-inited, and the allocator destroying itself because the message queue D-init deletes everything in it as well and then itself. So it'll handle that for us, which I think is a good abstraction. Because it leaves it up to the data structure and not the thing I'm using, if that makes sense. In my mind, it does. Right, but so if we want to receive a new message, we obviously just need a function that receives a message pointer. We're going to enqueue it. We're going to start our wait group. And then we're going to spawn a new function to actually do the thing, spawn process message. And so then we're going to get that message that we just enqueued. We're going to defer this ending, and then your struct is going to receive it. But this is on the thread pool, right? This is what we're spawning on the thread pool, and then we're going to D-init the message as well. Right, so we're starting the wait group here. And so then if we want to wait for all the actors' messages to get done, we can say self.waitGroup.wait. So that way we don't have to do these weird sleep things, and you don't have to iterate through anything. It's right here. I'm just using a wait group. So that way, like in a test, let me find something right here. Right, engine.wait for actor, and you could wait for a specific actor ID. Or I think I have I'm not sure I have a wait for all. It's almost like I don't have a wait for all, but it's almost like I wrote it, right? Right, but let's keep going. Stop does exactly what you'd think. It stops everything, and it dequeues all the messages and it's the it sets the flag to false. Like stop flag is true. I mean, so that way it'll stop doing its thing, and then it gets rid of all the messages in there. I'm surprised this isn't a double free. I didn't even realize I did it like that. But okay, it works. Just to prove that it does work. There was me doing my GitHub stuff. There we go. Zig build test works. Now the engine is where everything gets a little cooler, I think, and where the stuff actually gets done. So the actor handles is like a reference to the actor, I think is a good way to say that. But not really. It's like a way for me to just say, like, okay, you're giving me this actor, and I need, in my engine, a consistent way to handle all of them. So I'm going to make these handlers, which is basically my way of consistently managing everything, right? No matter what type you give me, I just need this, which is what's going on. So that way my types can be consistent. This is the periodic sender for the like send every and stuff like that. We'll get into that in a second. So yeah, in our engine, we have an actor map, an allocator, all the actors, which is an actor map. The next ID, a mutex for just stopping and stuff like that, and a thread pool. So when we make everything, when we initialize all this, we pretty much just do our thing, right? We just go through and initialize it all. This stuff is just abstracted out for this stuff is abstracted out for us in a lot of languages. So let's get into something cool, like spawning actor gets a new actor of tstruct and assigning it a unique ID. So the actor ID is just the next one, the next actor ID, right? And again, checking to make sure I have these methods or functions. Is it methods or functions in Zig? I don't even know. And so then we're initializing a new struct, error deferring if there's an error, and then defer the D in it. And then the actor is, actually we need to defer that anyway because I'm making the actor handle, right? So the actor itself is a T struct in it, and we're giving it, what's the actor that in it for the T struct, right? And we're giving it all this stuff. And then the handle is an actor handle, right? And then I'm storing the handle. Get it? So no matter what kind of thing you give me, no matter what kind of struct you give me, I'm going to make it into an actor and I'm going to make the handle. So that way I have consistency when I store these types in a data structure so I can manage them. And I'm giving you back an ID. This ID is what you reference things in the engine by. So when I want to send a message, I need to be given an actor ID and a message pointer. So then if I can get the actor ID, if I can get the actor by ID from the hash math, right? If I can get it from the key, then the handle pointer is the actor handle. So then I can use the send function in the pointer, right? And then I can do what I need to do. This is that consistency for me on my side. I'm going to go back to where I was. So where does it get called? Right here. Right? So then send every is I need a periodic sender. We'll go to that in a second. And then we're just going to start it, right? Because we're giving it the message and the delay and the ID. So we're going to go to that for a second. I want to get through the rest of these first, and then we're going to go to that. Wait for actor does the same concept as the send message, right? We get the actor handle. We get the reference to the actor handle, the pointer to it. Yeah, we get the pointer to it, and then we wait for that that actor. Wait function for the actor pointer, and yeah, it's I don't want to say self-explanatory. That's not. That was a little fucked up. But I already said wait, right? I already explained what that is. So it's pretty much just the abstraction for that. And again, I think it's a good abstraction because it leads to consistency. I think this is a good layer. I think this is a good level of abstraction for this stuff because I think it makes the experience of writing it pretty good and is consistent. So then if I want to get the actor state, then again, I look for the actor by actor ID, I get its pointer, and then I pretty much just do this type casting stuff, align cast, pointer task, and then as, so that way I can kind of get it back, and then I return the actual thing in it. Or it's not found. Poison all gets rid of everything in it, and then D in it, of course, it calls poison all, and then it D in its all the other stuff in it. So, about 18 minutes in, that's pretty good. Let's go through here. I guess store messages to how do I want to say this? So that way ownership isn't a problem, right? Take a sip of water real quick so I can keep talking. Lovely. So yeah, send messages, or stored message rather, is what we're is the array list of messages that this test struct is storing, right? So every time it receives, it appends it to that. That's the whole idea that it's doing, right? So here's how pretty much to use it. So when you have an actor like this, you have an init, a dinit, and a receive. I want to see something. Do I need that thread protection there? I don't. Sick. I didn't think I saw that and I was like, uh-oh, but I'll update that. But yeah, I don't need that thread protection there, so I'll get rid of that. And then before I forget to, I'll get rid of the qmutex in here. Why are you yelling at me? I was just saying that you're modified. Cool. Let's make sure that still passes. Sweet. Okay. So our receive takes this message and it goes through the instructions. If we get a custom message, then we do what we do. we pretty much just append it all because we just have to do some copying, right? So we get we copy it all over, so that way ownership isn't a problem, and then we make a new stored message, and then we append that to our messages, and we'll say that we receive it. We don't see that because it's in its own test directory, regardless though. And then if we get a function, then we call the function with the context and with itself, right? So now these handlers, this kind of handler is pretty dang important. This is what actually calls the stuff when we want to do a function payload, right? So when we do a call, we get our message handler and we get our actor, right? This is what you're controlling. This is what you're doing. This isn't my doing at all. You need to make your message handler and your actor. So then in this call, you got to do whatever you got to do. This is the way that the function is calling to append messages, right? And then it can also D in it, and it can also clone, right? New self. Clone the messages, I mean. Clone the handler, excuse me. Right. So again, these tests, simple stuff like initialize the engine, passes. These all pass, of course. Initialize the engine, spawn an actor. Is you have to initialize the engine with your allocator, the thread pool options, and the initial size for how many actors you have. Default is 16 because I need to fix that size, and then it can dynamically update or dynamically resize with the use of mutex. So yeah, then we could get our actor ID back when we spawn an actor with our test actor. Sending and receiving a message. So this is like what your code would look like, right? You would make your handler to process function messages. You would make your actor to do whatever you want to do. And then you would be able to say message make custom payload, whatever you want to do. And then you would be able to send it, wait for an actor, and then get the actor state. And then you could actually it's like get stuff out of the actor. Like you're modifying your actor with the engine, so that way you can do stuff on the thread pool concurrently and stuff like that. You can have actors send other actors messages. That's a thing that's allowed. So yeah, that's the point to use something like this, is for that kind of performance, and for, again, like I was saying before, I think, and for consistency. I kind of like when I make it, right? When I make something, I like to have the guardrails. If I could choose what guardrails I want the guardrails. Something that I heard a while ago was that all software sucks. So either use someone else's sucky software and understand why it sucks, or make your own sucky software and understand why it sucks. So this is like my way of making sucky software is like this, pretty much making my actor, making the handler, and then sending messages like this, right? So then if I want to send and receive handler messages, I would just have to make a message handler, make my message, and then I can make a, I said that a little fast, make my handler that is a message handler, right? Populate everything like that in there. And then, right, because this is where I'm making my payload and stuff like that. And so then I can make my message, and it is a function payload. So then it is the call in my message handler.call, the one up there, all the way up there. And the context is this handler. See how it's all woven together? And then I could send this message, wait for my actor, and we're good. Creating custom message, pretty much the same thing. Multiple actors, multiple messages, exactly what I was doing before, but just with loops and with two actors. Make sure that they all come in order because it's a queue. That's a feature, not a bug. High value of concurrent messages is just two actors receiving things at the same time. Yeah, two actors receiving two different things at the same time. Multiple message handlers. For all the payloads that we have, making them and sending the messages and then waiting for it. Yeah, that's pretty much what's going on. If you want to use the handler directly, you could. You don't have to send it to the engine. And then cloning the handler clone duplicates correctly. It all yeah, these are the features. I'm not even too sure what else to talk about. I had a professor one time said that the hardest thing to explain is the thing that you understand the most. And after coding this a little bit, I'm like, what do you mean you don't get it, right? Yeah, of course, it's pretty much brand new. I haven't made something useful with it yet. Other people haven't also because it's brand new. But yeah, I'd like to see what you guys do with this. I'd like to hear and get feedback from you guys. Also, I don't need to have this mutex in here now, I realize, because I got rid of it in the other thing, right? So I can push these changes now. Thanks for pointing that out, guys. Appreciate it. Can always count on you guys. But yeah, I hope that you guys make some cool stuff with this. I hope that you guys use it. It's open source on GitHub, right? Even if you guys don't, again, it's something that I wanted, so I'm probably going to end up using it eventually. I hope that the interest in this didn't fizzle out for me when I actually had to make it. But yeah, the experience for me to make this, being somebody that predominantly writes Python, Go, PineScript, even when I want to like script something quickly on TradingView, it's a big slow. It was initially it was felt like a huge slowdown for me to care about ownership. Where's this memory going? Oh, I have to deinit the individual things in an array list, right? And then deinit the array list. It's that whole process, that whole I'm actually in control of every allocation here and stuff like that. And so it's incredible for performance. There's a lot of fine tuning, a lot of performance to be found with this. But when when one day you go from pandas and NumPy to allocators and Zig, right? And you're trying to figure out why you have a memory leak, or you're figuring out why you have a seg fault when you weren't caring, you weren't keeping track of the ownership of something that you were passing around, and now you have no idea where it is and how to deinit it. That's why this function exists, right? It becomes something that's it gives you a different perspective, right? And it's better or worse, I don't know, I don't care, but it's different, and it's kind of cool to think that like the amount of seg faults and stuff like that I had, the amount of memory leaks I had when I was originally writing this, and I was like, and something like C or C++ would just let it be until it was found later on, and it was just a total disaster, right? The Zig compiler I think is great, and I like that in build.zig you could do stuff like depend on running my tests, right? That's quite nice. So yeah. Also, I'll talk about AI and writing this as well, because again, going from, especially with the data structures, going from again like the quant finance aspect of it, like pandas and NumPy, visualizations, volatility equations, trying to make strategies and explain stuff just using simple web dev, right, and Go and like database stuff. And then it's like I want to implement one of these lock-free queues, and it's like, well, this is great, and I didn't think about it. So I kind of just want my implementation. I want an understanding of how it works. Like, okay, we're comparing and swapping atomics. Like, we're comparing and swapping values is how atomic works, and it's a linked list. That's why we don't need a lock, because these atomic values, because of how we're storing it. It's nice, but that's not what I want. And I don't mean to say that in like a entitled way or anything like that, but like programming is a huge field. It is very vast and diverse. And so jack of all trades, master of none, like, no, I don't want that. I want jack of all trades. I want jack of 2 or 3 trades, master of 1, right? That's the direction I want to go, with just being nasty at what I want to do. And in other aspects of programming, sure, it'll slack off a little bit. And so that's when this AI power of one thing comes into play. Also, though, I don't know if you've ever tried to use an LLM to write Zig. Sometimes they suck. Sometimes they just don't do at all what you want it to do, and it's very frustrating. it's also writing it in a stupid way, so that way you know what you do want. When I initially wrote this, it was way simpler. Messages didn't have that builder stuff or cloning, and each actor got its own thread. I spawned a new thread for each actor. That's not how you should do it, right? You would like, preferably, to have that consistency in the builder functions and the messages. That's kind of just nice. But you can't spawn a thread for every actor. That's just not necessarily how it works. You'd run out of resources very quickly. So if you're going to do anything remotely large. And so then when you use a thread pool, and it's like, okay, so now this engine has a thread pool, how am I going to make my actors do stuff on it? Well, okay, I could pass this reference around. Okay, cool. I don't want to use time dot sleep in my code. How do I wait for it? And it's like, well, you could use a Boolean for each thing. It's like, no, I don't want to do that. That just sounds very annoying. So then, okay, I know that Zig has wait groups in the same library. I've used wait groups in Go. They're cool. Let's implement this, right? And so, yeah, I think that there's something in implementing it a crappy way at first. But I don't know. I still wrestle with that in my head. Like, is there merit? Is there any nobility in... Is there anything to gain by not implementing it correctly the first time? And I don't know. I'm 20, right? I'm 20. This is my semester. This is my summer from my last semester. And so it's like, I think I should be easier on myself for implementing things in just a abhorrent way the first time. And then later on, doing it better. Because yeah, now that I've done this, next time I write something, it'll be automatic, right? Take that main thing, give a thread pool reference, whatever. Oh, I have these things, and I'm struggling keeping track of where they're going in their seg vaults and stuff like that. So how about I just eat it and just make a clone, right? And so that way I could just send that around. So that way I know exactly where it is, right? The only wrong way to do it is by not doing it, right? Eventually, you learn and you do stuff, right? Do the kind of programming that makes you get up in the morning. Subscribe to my algo with Lux Algo to help out your boy and to help out yourself. It is a cool indicator, right? But yeah, I'm gonna push these new changes, and yeah, you guys have a lovely, lovely day. I'll be back with more content soon.